Hey everybody, welcome to 8.6 Solving Natural Logs. So basically, I made this a separate section because we're going to be doing all the different solving things that we did in section 8.6, only now using E and ln, and it's actually not any more difficult. Students just sometimes get confused about the fact that it's actually possible. So I just want to remind you about a few things. Remember, to start off with, remember that if you have a base of E, that's when you have the ln of x. And really, ln of x still has a base E. So if I had a statement such as e to the x equals something, in order to cancel out the E, I want to do a natural log. Because really it has a base of E, and then if this base and this are the same, that cancels and is just equal to x. The other property we're going to use today, if I was going to do the log property, remember this, let's say I had 4 to the log base 4 of x power. If that 4 and that 4 are the same, it's just equal to x. Same thing applies if I have a E, and then because a natural log has a base of E, it's like E, those cancel out to just be x. Keep in mind though, they're not going to say ln base E, they're just going to say ln x. You have to know that there's really a E there, so it cancels. This section then is going to be very similar to what we did before, so I'm going to move through this a little faster than I did lesson 8.6, and I'm also going to give you some time to solve some of these on your own. Just to start off with, look at example A. So I want to just remind you from what we did in regular section 8.6, let's say I had this. Let me make it a little harder. In order to cancel out the 4, remember you did log base 4 of both sides, because that is the inverse of that. That cancels out, and then in my calculator I would figure out what log base 4 of 18 is. So again, I want this and this to match up. Right now my base is a E, and the thing that matches up with a base of E is the ln, because it has a base of E. So I'm going to take the ln of both sides. So in my calculator, type in ln of 72, and it's approximately 4.3. Go ahead and do part B. Getting for your final answer for this, x is approximately 1.607. And notice we're going to be doing the approximate answer again today. So at this stage, what I typed into my calculator was ln of 124, and then to get rid of the 3, I had to divide both sides by 3. Notice that today we're going to do 3 decimal places instead of 2 decimal places. Alright, moving right along. Just like we did the other day, before I take the log, or ln log this time, of both sides, I need to get the thing. In this case, it's not a base, so it's going to be E every time, but I need to get that E by itself. Notice how 3x minus 2 are both part of the exponent, so I can't do anything with those yet. You can't touch them until after you got rid of the E. So in this situation, I have to get rid of the 12 first. I divide by 12, I end up with E to the 3x minus 2 power equals 8/12 reduces down to 2/3. Now I'm at the stage that I can take the ln of both sides, and I end up with 3x minus 2 equals, type that into your calculator, approximately negative 4.405. And now at this point, it's just a normal equation. So add 2 to both sides, divide by 3, x is approximately 0.532. Right now, I want you to pause the video and try D, E, and F, and then when you unpause, I will have the answers showing. So be ready to check your answers when you unpause the video. Alright, if you have unpaused and you're checking your answers, at any point make sure you pause the video and write and copy some of this down if you didn't get it on your own, and you can definitely ask me some questions in class. The only thing notable about D is that it did have a negative x, so that negative was still there. So for my final answer, I had to divide both sides by -1 for D, and you should have had approximately negative 2.71. Alright, E, you should have had approximately 0.963, and F approximately 0.768. So again, pause the video and look at those a little more closely if you need to. I'm going to now move on and talk about going the other way. Instead of being given E, now we're going to be given the ln of x. Natural logarithm equations. We're going to solve for x again. We're going to round to 3 decimal places, and remember again, same thing I said earlier, base E and natural logarithm are inverses. So here's what I mean. So in order to get rid of a ln of x, or in order to get rid of the ln part of it, we're going to take both sides as powers of e. We're going to exponentiate. And let me show you what I mean. But in these situations, before I do that, I have to get this by itself. So right now, I'm going to have to get rid of that 5. And I'm going to have to get rid of this 2. So I divide it off. And now I get ln x equals -1/2. Now here's what I'm saying. To get rid of the ln part, because our goal is just to have x by itself, right? Because it's a really log base e, to get rid of a base e, take both sides as powers of e. And again, if you want to write it out longhand, this is what we're doing. E to the ln of x equals e to the -1/2. And again, shorthand is just write the e there, but I end up with x equals, type this into your calculator, and you end up with approximately 0.607. Let me show you b. So same situation, have to get the ln x by itself. I subtracted 2 from both sides. It's -3 times the ln of x, so I'm going to divide by -3. I end up with ln x equals 1/3, and now is where I exponentiate. So to get rid of a ln, take both sides as powers of e. And right now, it might be hard to tell, but both of the 1/3 is now a power of e, ln x is a power of e. So that's on the left side just equal to x. On the right side, type that into your calculator, e to the 1/3 power, and I get approximately 1.396. When you are done with that, flip to the back again, pause if you need to at any point. I am going to let you try C and D on your own, so go ahead and pause the video, and when you unpause, the answer will be showing. Here's our answers for C and D. When you're finished with that, scroll down, and I'm going to talk about E and F. So these ones are more complicated because I have more than one log in the same problem, and here's where those not exponential properties, but the log properties we learned the other day are going to come into play. So remember, if I have a plus sign in between two logs, if I condense this, those are multiplied together with a single log in front. So in this situation, the only confusing part was knowing that you had to condense the logs. Once you get to this stage, it's actually a rather easy problem. I take e as bases on both sides, and e to the 7th power is 1096.633, divide by 2, and I'm left with x is approximately 548.317. Alright, and then for F, there's a lot going on in this problem. First, to do this, I would add 5 to both sides, just so that my logs are by themselves without anything else there. So the rest of the left side stays the same, and now on the right side I've got -3. Alright, we are going to condense this part, and now think back to condensing. The first thing we did when we were condensing was we had to get rid of the number that's in front of my log. So if you remember, that becomes a x, or multiplies, or becomes an exponent, I guess. In this situation, there already is an exponent, so I'm going to multiply them, but I do not move the negative sign. That just is still there. So let me recap. So here's what I've got, and then the 4 moves and becomes an exponent as well. Everything else stays the same. So now watch what happens. You might want to just erase this and pencil in the new thing here. When I have a power to a power, remember I multiply them, and a 4th times 4 is 1. So really, now it's just ln x to the 1st, or just ln of x. I also right now have a subtract sign, so I'm going to use the property that says when I have a subtract sign, I'm going to condense it to a single log. The stuff that's positive goes on top, and the part that was negative goes on bottom. And here's what I've got. Once you have the single ln, now is where I'm going to exponentiate. I take a e as a base on both sides, so I'm left with x plus 4 over x is approximately 0.0498. And now I've got a tricky problem. You might be feeling kind of confused in how to solve this, here's what I would recommend. Pretend like it's a proportion and we're going to cross multiply. So x plus 4 times 1 is just x plus 4. X times 0.0498 is 0.0498x. And then if I'm solving an equation, I want to get all of my x's on one side. So I'm going to subtract off of x from both sides. And I'm left with 4 equals 0.0498 subtract 1 is negative 0.9502x. And it's not that hard at this stage, it just looks really gross, right? I've got these long decimals that I'm typing into my calculator, but actually it's not any harder right now than what we did before. You actually end up with negative 4.210. And what happens is, when I put in negative 4.210 back into the problem, and like I said earlier, I will tell you what situation you're going to have to check your solution in. It will specifically say, check your solution. But when I plug this back in, I end up with a negative right here, and that is not possible. So that's actually an extraneous solution, and we only had one solution to start off with. So actually the answer for this problem is no solution. Alright, thanks for listening. The rest of the problems we're planning on doing during class, so we'll catch you again in Chapter 9.